All right. So we're just start off with some review. First thing here is just rationalizing the fraction. So the way we rationalize is we can get that radical to be in a different location by multiplying the numerator and denominator by that value. So anything we do to the top, we can also do to the bottom, and we're able to maintain the exact value and nothing changes. So we're able to maintain balance. So to get that radical 5 to be out of the denominator space, we're going to multiply the top and the bottom by square root of 5. So the numerator becomes 2 root 5. The denominator, root 5 times root 5 is root 25, which is basically anytime I multiply two squares together, the radical goes away. I'm just left with that value inside. So this is 2 root 5 all over root 25. We can skip this step and just go directly to 5 because we know that root 25 is 5. So we can jump directly here if we like. Root 5 times root 5 is just equal to 5. Okay, solving basic equations. 12 equals x over 3. Anytime I see a value equal to another value, especially if there's a denominator involved, I like to just force a denominator on both sides. So I can always put a denominator under a whole number, right? 12 over 1 is equal to x over 3. So visually, I like this because I can just cross multiply. I can set the diagonals equal to each other. X times 1 is just x. 3 times 12 is 36. So x equals 36. Okay, so apply that same step for the next part B for number two. 20 equals 5 over x. Okay, try that. X equals 5. But here we have one more step remaining. What can I do to get x by itself? Divide both sides by 20. 20 moves to the right side, 5 over 20. Use this to be 1/4. Okay, number 3, how do you solve for x? Yep, subtract 7, that's an easy one there. X squared equals 30. How can I get x by itself? Square root. Now, there's something special that happens here when we take square root. Something pops up on the right side. Plus or minus, okay. Now, plus or minus is only going to show up if you take the square root of an equation. Okay, so here I'm going to get x is equal to plus or minus square root of 30. So there's two solutions, okay? However, if you just see square root of 30 by itself, then it's just going to be square root of 30. Okay, so when you take the principal square root, we don't have to worry about plus or minus. Plus or minus is only going to show up if you're taking the square root of an equation. Okay, that's the only time plus or minus shows up here. If this just, let's say if it's just radical 25, it's just equal to 5. Okay, it's not plus or minus 5. So just make that distinction there. You only got to worry about that plus or minus if it's part of an equation that you got to deal with square roots, where you're introducing square roots into the equation. Good so far? All right, bottom of the page here. We're dealing with, so we're talking about trig here, study of right triangles. Adjacent, hypotenuse is always the same, right? It's always the angle or the side that is opposite the right angle. So I know that hypotenuse is never going to change. It's always across your 90-degree angle. Now, adjacent and opposite changes depending on where you're standing, okay? So if we're talking about this angle here, then relative to this angle, adjacent and opposite is going to be different, right? Opposite means the other side, right? Across from the angle, and adjacent means touching or next to, nearby. Meanwhile, if my angle is all the way up here, then my adjacent and opposite is differently defined because of my location, right? So if I'm starting from this angle's perspective, then opposite or across is now going to be this side, and adjacent is next to it, right? So we can never just look at a triangle and decide adjacent and opposite without first knowing, where are we from which perspective, right? Which angle are we deciding adjacent and opposite from? So that's important to be able to know where the angle that we're starting with, and then we can name the sides appropriately. Okay, so I'll do example one. Let's do example one together, and then I'll have you guys try number two, and I'll walk around and see how you guys do. So it says find the sine, cosine, and tangent of angle A. So angle A is going to be our reference points. We're going to be looking at the triangle from the perspective of angle A. And we want to find sine, cosine, and tangent. So remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now we have the two sides defined, but we don't have the hypotenuse. What's a way that for us to find that missing hypotenuse value? Yeah, Pythagorean theorem, right? Anytime we have a right triangle, we can use Pythagorean theorem to find missing sides. So Pythagorean theorem. A squared plus B squared equals C squared. This is a common Pythagorean triple, but we can also work it out by hand. 5 squared plus 12 squared equals C squared. Ends up giving us 169. We take the square root, C equals 13. Okay, so let's go ahead and find sine and cosine and tangent of angle A. So we'll find sine of angle A is equal to the ratio of opposite over hypotenuse. So sine of A equals what? Okay. Cosine of A adjacent over hypotenuse. Tangent of A 12 over 5. Good. All right, go ahead and try number 2. Follow the same procedure there. Yeah, I'll just tell you, the hypotenuse is 25 here, Pythagorean theorem. Okay, let's check our answers. Okay, any questions? All right, let's look at the next example. Same process. It's just that now we're going to find all 6 trig ratios. So we'll talk about, we'll include now the reciprocal of sine, cosine, and tangent, which is cosecant, secant, and cotangent. So we start off with Pythagorean theorem. A squared plus B squared equals C squared. If you don't have your calculator, I can go ahead and work that out for us. Okay, so as a reminder, the reciprocal of sine is cosecant. The reciprocal of cosine is secant. Reciprocal of tangent is cotangent. So because sine is opposite over hypotenuse, cosecant must be what? Yeah, hypotenuse over opposite. Right. Cosine is adjacent over hypotenuse. Hypotenuse over adjacent. Opposite over adjacent. Adjacent over opposite. And so any fraction that you get for here, you can just go ahead and flip them. That will be for the corresponding. Okay, so try these, see if you can try number 1 and go ahead and try 2 as well. Okay, let me just see how you guys do. So angle A
A. Oh, I'm sorry. It should say angle theta. So theta is here. So put a box around theta. So because you're standing here, that's adjacent. That's opposite will be the furthest away. Yeah, sorry about the the example says for angle A, but it should be angle theta, because that's what is defined. So let me change that. Angle theta. Okay, check your answer for number 1. Questions here. It's like everyone was fine when I walked around. Okay, try number 2, see how far you get. Okay, for number 2, eventually we're going to rationalize the denominator, but initially just don't worry about the radical in the denominator. Just get all the ratios down, and then we can clean it up after you get your initial ratio. Okay, this one. Okay, let's check how we did initially for number 2. Pythagorean theorem will allow us to find that missing leg, a squared plus b squared equals c squared. Remember, we don't want to do 2 squared plus 5 squared equals c squared, right? The c is the hypotenuse, so it's in this case, you can use any variable. I use x, you can use a squared, you can use a or b, but you can do x squared plus 2 squared equals 5 squared. And we should get root 21 as the adjacent side. Okay. And we can't radically the calculus, right? Right. Well, I think yeah. So no radicals in the denominator. But initially, let's just talk about making sure that we can get the ratios, and then we can do cleanup. And the only one that requires cleanup is that tangent theta. Okay, so sine and cosecant are reciprocals. Cosine and secant also requires cleanup as well. And then tangent requires cleanup. Okay, so initially, sorry, I think I jumped to the end for secant. What you guys get for secant initially? 5 over root 21. Okay, so if I want to clean up 5 over root 21, what can we do? Let's target that denominator, or we want that to be a different form. So we multiply the numerator and denominator by root 21. This is going to clean up nicely. Root 21 times root 21 is just 21. The numerator just, we don't cancel these out, right? Because these aren't in the same places. Tangent, same thing. 2 over root 21. And if I want to clean up that root 21 in the denominator, I can multiply the numerator and denominator by root 21. And tangent will give me 2 root 21 over 21. Okay, any questions? Let me know if you want me to clarify anything that we just went over. Okay, does anybody still need this page? Okay. Let's go to the bottom here. Now we're going to have to build a triangle here and kind of build it from scratch. Okay, so next example, given that cotangent of theta is 13 over 9, find the other 5 trig ratios. Let's build our triangle. So I'm just going to put my triangle in the first quadrant. That's going to be an easiest way to build a triangle. And I'm just going to call my theta this. I like to just build my triangle this way. Down the road, we're going to be building our triangle in different quadrants, but we're just going to always assume first quadrant unless they tell us otherwise. Okay. And then whenever you build your triangle from the origin, we're always going to put theta here. This is going to be good down the road when we talk about unit circle. Okay, so it's kind of a good thing to kind of build for our habits. Okay, so theta, we put it nearest the origin. And then cotangent is 13 over 9. What's the ratio definition for cotangent? Okay. Yeah, adjacent over opposite, right? Because we know that tangent is opposite over adjacent, so cotangent must be the flip version, adjacent over opposite. So I can put the 13 in the adjacent side and the 9 in the opposite. Remember, we're looking at the triangle from the theta's perspective. Okay, Pythagorean theorem will help us get to that missing hypotenuse side. And if you don't have a triangle, I'm sorry, if you don't have a calculator, I'll go ahead and work this out. Okay, now technically, when we take the square root of both sides, if we were to solve this equation, technically we should have a what? Right. Plus or minus, right? But why do we not deal with the negative here? Why do we not worry about that there could be a negative root 250? Yes, it's side length, right? It's a side length, so we're just going to treat every side length as positive, right? So no negative side lengths. Algebraically, the negative makes sense, but for our because we're talking about sides of a triangle, we're going to ignore the negative. Okay. So now root 250 can be broken down further. There's a perfect square hidden inside, and the perfect square is 25. So if you imagine 250 as 25 times 10, I can pull that 25 out, right? What's root 25? 5. So 5 escapes out from under the radical, but the 10 stays. So C is 5 root 10. Okay, so starting from this point, see if you can find the other 5 trig ratios. After you find the ratios, see if you can clean up if any needs to be cleaned up, removing the denominator. Removing the radical from the denominator. Okay, so try that, and then I will put the answers up for us to double check. Yeah. Just root 10. Yeah, good question. Yeah, so if we have a radical. Let's see how we did. Let me know if you have any questions. I can go over any parts that you want me to.
This after we put the 5 and 10 or 9 and 10, the 9 50 over 9 and 10. Opposite.
Oh, for secant, you mean?
No, for the CSC.
Oh, cosecant. Okay, so for cosecant, all I did was I took the original sine and I just flipped that. That way I can just reduce the amount of work. Okay. Rather than flipping this, and I flip that, I gotta do more work. But yeah, but cosine initially is 13 over 5 root 10. Multiplied by root 10. Okay, root 10 times root 10 is 10. 5 times 10 is 50. That's why we get that proposed.
Wait, why do you multiply by root 10?
Okay, because this is technically correct, but whenever we rationalize the denominator, we want to try to get that radical to be moved to a different place.
So because I want that root 10 to be removed from the denominator, I'm gonna multiply the numerator and denominator by root 10 to allow that to shift to a different location. So root 10 times root 10 is 10, and 10 times 5 is 15. Okay, what's the comfort level here? You guys okay? Okay, all right, let's do a few more. And then I would love to get ahead in the calendar a little bit, just so that earlier we can get through all the new material, we can kind of have more time to review. But let's just do a few more, just get really comfortable before we move on. So the next page, I would just like for us to try 9, 11, and 13. Okay. We'll skip 1 through 5, 7. I think you guys are pretty comfortable with that. I want to make sure that we can build the triangle from scratch, just given one trig ratio. Okay, now notice that each of these can be written as a fraction. So sine is 4/5, cosine is 5/9. Now 3 doesn't look like a fraction, but I can always make it what? 3/1. Yeah, so that's how I would do it, can't make it 3/1, and then you can match up the appropriate sides. Okay, so try those 3 real quick. And then we'll try to use the remaining time to get a head start into the next section. Okay, I'll walk around, see how you guys do. Answer any questions, make sure we're comfortable. Hey, raise your hand if you did not bring a calculator today. Okay, but you guys all have calculators?
Yeah.
Okay, yeah, so just bring it tomorrow. We're gonna need it tomorrow. I will send out a reminder this afternoon for you guys to make sure to bring one.